look at practice question set number 4 that was due for homework for today, everyone. 4 questions, starting with numeric response question number 1. It says a proton collides with a stationary alpha particle. You guys all know what a proton is, right? Proton is in the nucleus of an atom. You learned that in grade 10 or grade 9 or grade 8 or something like that. An alpha particle, on the other hand, you probably don't know what an alpha particle is. I'll tell you right now that it's a product of radioactive decay, but that's not something you really need to know for this question. You need to know it's a particle. It's something that collides with something else. Now, you need to know something about the proton and the alpha particle, specifically the mass, but nothing else, not where it comes from or so on. What is the mass of a proton? Well, if you don't know the mass of a proton or an alpha particle, it's not given to you in your question, where do you think you might find it? Where do you think you might find mass that isn't given to you in the question? In our data booklet, exactly. The mass of a proton, we're going to call the proton mass number 1. The mass of the proton is 1.67 times 10 to the minus 27 kilograms. And the mass of the alpha particle, we'll call that mass 2, is 6.65 times 10 to the minus 27 kilograms. Again, just simply from our data sheet. The alpha particle is stationary, so we're going to say V2I is 0 meters per second. Now, the rest of it gets a little bit confusing. It says the proton collides with a stationary alpha particle. After the collision, the proton moves opposite to the direction of its initial motion. The alpha particle moves in the same direction as the initial motion. So if we're looking for V1I, and that is what we're looking for here, the initial speed of the proton, and we're going to assume that V1I is the positive direction, which I am going to assume that, then that means V1F, opposite direction, V1F is going to be negative 3.35 times 10 to the 6. Now, we could have assumed that the final velocity would be negative, and the initial velocity would therefore be positive. I just assumed the final would be positive, the initial will therefore be negative. Now, the alpha particle, that's object number 2, after the collision, moves same direction as the initial motion of the proton. So that's going to be a positive value. We're going to say V2F is equal to positive 2.25 times 10 to the 6 meters per second. Do those signs make sense? Positive and negative? Bottom line is V1F and V2F have to be opposite signs. One of them is positive, one of them is negative. Which one is which? Doesn't really matter. The way that I did it, I assumed that the alpha particle was positive and the proton was negative. All right, this is collision, so we're going to say Pi equals Pf. We're going to say M1 V1I plus 0, because the alpha particle is at rest, equals, they don't stick together, they bounce off of each other, so it's going to be M1 V1F plus M2 V2F. Okay? Now, you guys probably didn't notice this, but an alpha particle actually has a mass of exactly 4 times the proton. So what you could do, as opposed to writing the masses given to you in here, you could actually write in M, M, and 4M, and then cancel out an M in each term, and avoid these crazy exponent numbers. Does that make sense what I just said? If that doesn't make sense, then just plug in the numbers as we're given the numbers. M1 is 1.67 times 10 to the minus 27. V1I is, that's what we're looking for, plus 0, 1.67 times 10 to the minus 27. Another thing you could do is what? As opposed to 1 and 4, what appears in every term here? Negative 27. So you could cancel out the 10 to the negative 27, right? And just be left with 1.67 and 6.65, right? V2F is 2.25 times 10 to the 6. You can't cancel out the 10 to the 6, even though it appears in every term on the right-hand side, it's not on the left-hand side, so can't cancel that out. I am going to cancel out the 10 to the 27, 10 to the negative 27, even though you don't have to. Just makes for a little bit easier math here. We'll pull up the calculator here. Say 1.67, sorry, let's do the right-hand side. Negative 3.35, sorry, mistake again. 1.67, yes, times negative 3.35 times 10 to the 6. Press equals, and then let's add to that 6.65 times 10 to the, drop the exponent, I guess, times 2.25 times 10 to the 6. And let's divide that by 1.67 times 10 to the, just 1.67. 5.61 times 10 to the 6. Meters per second. Now we express that as 5616. There is a typo here. It says A decimal BC times 10 to the negative D. It should say A decimal BC times 10 to the positive D. All right. Number one, multiple choice number one says a clerk working at a local food store is asked to retrieve empty shopping carts left outside by customers. Each cart has a mass of 20 kilograms. Although it doesn't really matter. If all the carts have the same mass, it doesn't really matter what it is, right? Because we could end up canceling that if we wanted to. So we got eight shopping carts on a slight incline, 12 carts. 12 carts are going towards the 8 carts here. So 8 carts are going at 2.3. We want to know how fast the 12 carts are moving towards the 8 carts. So it's like this, guys, right? Here's one set of shopping carts. Here's another. They're coming towards each other. What happens when they hit each other? They stop, right? They come to a complete stop. We're going to say PI equals PF. We're going to say M1 V1I plus M2 V2I. Two objects, right, before the collision takes place, equals what? What's the final momentum after they stop? Yeah, or just zero, right, because they come to a stop. Hey, what's the initial momentum? What's the total initial momentum equal to? M1 V1I plus M2 V2I, right? But numerically, the initial momentum is equal to 0 because it's equal to the final momentum, right? M1, we're going to say is 160 kilograms. That's the 8 carts. V1I is 2.3 meters per second. M2, we're going to say is 240 kilograms. That's going to be the 12 carts times V2I. That's what we're solving for, V2I. And when we do that, it works out to be 1.53 meters per second. In numeric response number 2, a 2,100 kilogram van collides with a 1,200 kilogram car that's at rest. They lock together, move off at 4.5. This is a pretty straightforward one. PI equals PF. We're going to say, bless you, 2,100 kilograms times V1I. That's the initial speed of the van, plus 0, because the second one is at rest, equals, says they lock together, so the total mass after they collide is going to be 3,300 kilograms. They head off together at 4.5. We're going to solve for V1I there, and when we do, V1I works out to be 7.07 meters per second. Now, they're not asking me to express this one in scientific notation, so if this happens to be a numeric response question where you actually have to bubble it in on a test, we bubble it in like this, 7.07. All right, and finally, multiple choice question number 2, which I said in the answer key online was D, it's not D. Okay, the answer should be A, 1.02 times 10 to the negative 1. Where does that come from? Well, these two bumper cars are coming towards each other, X and Y. They collide. PI is equal to PF. We're going to say M1 V1I plus M2 V2I. Then afterwards, they spread apart, or they bounce apart, so we're going to say M1 V1F plus M2 V2F. If the bumper cars were the same mass, that would be great. They're not. We're told that bumper car number 1 is a mass of 125. V1I is 2.25. Mass 2 is 161 kilograms. V2I, be careful here, is negative 1.3. We really should have circled east and west here to remind us of that, right? 2.25 and negative 1.3 equals, mass 1 is 125, V1F is what we're looking for. Mass 2 is 161 times V2F was 0.526, and that was to the east. So we solve for V1F here, and it works out to be 0.102, or 1.02 times 10 to the negative 1 to the west. Negative 0.102.